Hello, everyone, and welcome to Innovation Coffee, brought to you by ARM. I'm your host, Robert Wolff. This week and every week at 5 p.m. UTC, you may have noticed if you're in one of the Pacific time zones or any time zone that has a time change, then it's at a different time today. Today, we're going live at 10 a.m. Pacific, but it's always 5 p.m. UTC. So if you always follow the UTC clock, then you'll know that you'll find us at 5 p.m. UTC. Today, we have a very exciting episode for you. We're joined by Matthew Croughan, who runs his own software consultancy called Nix.how and is a DevOps engineer for Platonic Systems. He's here to tell us what he knows, everything he knows, and help us learn about Nix and NixOS. Now, Nix is a package management system. NixOS is an operating system, a Linux flavor that he is going to tell us all about, as I just mentioned. Now, if you do enjoy this video, don't forget to smash that like button and follow ARM software developers for all the cool stuff that we put out there this week, every week, all sorts of fun videos, and of course, live streams like this one. So I think without further ado, let's bring Matthew into the call. All right, Matthew, how's it going? Hey, what's up?
Excellent. Yeah, I just about got my tech setup working, and everything still falls apart, even if you use a reproducible build system like Nix. So no matter what happens, computers are still fragile.
It happens. It happens. Yeah. So Matthew, real quick, what we like to do at the beginning of every call, we want people to get to know you. And I know you've been on an Innovation Coffee before, and this was I think like a year or two ago now, right? When Alessandro was with us.
That's right. Yeah, I know I was a bit more pale then, and yeah,
we got to see your makerspace. I think you drove a robot around. It was pretty cool. I feel
yeah,
like
that's right.
Was it pre-COVID? I kind of feel like it was. Maybe it was like right.
No, it was during COVID. I had just gotten hired by Foundries, and then I sort of like stayed in my room and just did that. It was a lot of fun.
Very nice.
But yeah, that was there during COVID, just about at the start of it.
And then you played a song for us.
Yeah, something about Bellina. Yeah, I think that might be on a different podcast rather than this one. It might have been on the Bellina podcast.
Okay. Yeah, we'll have to check that out. I'll have to go back and relive that. But okay, cool. So Matthew, tell us a little bit about yourself. What do you do? Who are you? Walk us through.
I'm different now than I was back then. So now I do DevOps and software consultancy. And the main tool of choice I'm talking about is Nix, of course. And so I use Nix as an alternative to Docker and Docker Compose and all of these other build systems and deployment tools. And I've sort of crafted a niche for myself there.
Very nice. Cool. And so Nix, this is the topic of discussion. And, it doesn't stand for anything, does it? It's just Nix, not an acronym, right?
Well, the funny thing is, it means in German, it means nothing.
Oh, nothing.
Nothing at all. So that's you can just move on and not listen to me because you don't need to know anything. It's
nothing at all.
This tool doesn't mean anything. That's all right.
Cool. Well, so let's talk about it. Diving right in. And I know you do have a demo to show us too. So I think that'll be fun as well. But so tell us, what is Nix? What is NixOS? Maybe you could start by just what the two things, what are their differences here?
Yeah, so Nix is a functional programming language, and NixOS is an operating system that's built using that functional programming language. So, for example, Debian has dbootstrap, and that's how they build their images to deploy to people. That's how they build the RISO images. So everyone kind of has a build system. I mean, Arch Linux has pacman, right? You do pacman-s, install the thing, and it will install the thing, and that's how their operating system is built. Similarly, NixOS is built using Nix. So you run Nix, and you can get some outputs, and the outputs are particular to NixOS. Just like every other distribution has its own package manager, which is used as a tool to build the actual operating system that we all flash and install. Okay,
nice. All right, so I have some questions here for you. I know I dove right into Nix, but the last time we spoke, it was just through chat, and you mentioned this really cool kind of incubator space that you're living in, hanging out in, working in, and it's called Astral Ship. So I want to kind of pull this up on my screen and then share my screen. And then hopefully you can kind of tell us a little bit about what is Astral Ship.
Well, it says it right there. It's an optimized vehicle for human consciousness to change the game, which is marketing lingo for come and hang out with us. We're a bunch of hackers in the middle of nowhere in Wales, and you can live and eat there and hopefully get something done. That's really what it is.
Yeah, I was poking through this website here and reading about it, and I guess it's kind of like set up to feel or look like a ship. And I mean, I'm looking around at some of these pictures, and it just looks amazing. I mean, are you guys? So you guys are in there, you're hacking, you're working, building projects, but you're also kind of at the same time making this building better, building the building up, and kind of tailoring it to be a kind of space for productivity?
Yeah, that's right. If you actually go into a new tab and go to Nix.camp in your URL, you'll see some more pictures. These are more recent pictures, and this is an event that I ran last year. And if you scroll down, there's like a little bit of a light box, and this is kind of even more scenic. So on the bottom right, that image is the office. So that's the office space that we have there. So right next to the Rosetta window, and that's our source of light. And there's the Rosetta window right there in the center. And
oh wow!
Yeah, we just crafted the place out of the existing wood in the building, and it is what it is today. It's just basically a bit of a hackerspace like the CCC or something else you might have heard of.
And you weren't even joking. This looks like it is in the middle of nowhere. How's the internet service?
We have 100 megabit fiber line, symmetrical business fiber. Okay, so that was a bit of foresight from the owner, who is called Liam Kermos, who I've done a YouTube video with on my YouTube channel. And he decided to get that infrastructure put in there like 5-10 years ago, something like that. And there is infrastructure in terms of electricity and fiber in that area, thanks to him. And yeah, it's a great place to live and work.
Is this where you're joining us from right now?
No, I'm in another makerspace called Does Liverpool right now.
Okay.
And then I'm going to head back up there today, but I thought I'd sit down here with you for a bit.
Very cool. All right. Well, that's nice. Nice to hear. Thanks for sharing with us about Astral Ship. I want to pull this up one more time here in case anyone wants to go there. It's just astralship.org. You can go check it out. Yeah, I really like this. I mean, like I said, I was reading about it. It kind of feels like a very open, collaborative space. Like I can only imagine walking in there and, during, of course, working hours and maybe even in the middle of the night and just seeing a bunch of engineers and developers just hacking away, building cool stuff. So
that is indeed the case, and it is operating pretty much 24/7. We have around 3 engineers that kind of operate in that region at the moment, and the rest of them aren't even engineers; they're just normal people. So it's a bit of a combination, a polyglot of a cabal of hippies and hackers.
Nice, very cool, awesome. All right, so now back to the subject at hand once again. So Nix, I have these questions here I wanted to talk to you about. First of all, you mentioned what is Nix. I'm curious. So Nix, what makes Nix as a package manager unique compared to, other ones like, I don't know, Red Hat Package Manager, RPM, Yum, APT?
Well, actually, Nix started off as a thesis by a guy called Elko Dijkstra from the Netherlands in 2003. So that's how long Nix as a concept and what it does has existed. In the meantime, these other systems like Docker have come about, and they were developed alongside Nix, and Nix was sort of relegated to the corners, and it's kind of remains a bit of an obscure thing. The thing that makes it different is that it's deterministic and reproducible, which are kind of buzzwords that have been taken over nowadays. But what that really means at a fundamental level is that if I have an issue on my system, that issue can be reproduced on your system. Whereas right now, if I apt install something, then apt uninstall it, then apt install it again, I actually end up in a different state than I intended to. And in fact, if you do it on your system, there'll be something on your system that causes apt to behave differently in that circumstance, be it an outdated package repository list or something to do with key signing or signatures. There's something going on your system that's different from mine. And that is it's not easily possible in Nix because they've architected themselves out of the problem. So they control the input and they don't trust the internet. And that's kind of a trope in functional programming, is that we don't trust input from the internet unconditionally. We have to hash them. And there are elements of what Nix does in a lot of build systems, but in my view, Nix is the one that's done it the most successfully.
And I guess this is really important, right? Because, when something's going on, when they're trying to develop something, if you're trying to add to Nix or NixOS, if you're trying to recreate an issue, and communicating this, across the world or across the globe between developers, it can be difficult. I know that, when sometimes issues are presented to me, I have to, prompt the engineer or someone to say, okay, well, how do I recreate this problem? Right. And with Nix, I'm guessing now it seems like a lot easier to get that reproduced so that then the support can find a way to fix that issue. Right.
Yeah, and Nix introduces a bunch of concepts. One of those concepts is called impurity, which starts to sound a bit religious, which maybe ties in a bit with the fact that I'm coming from chapel in the middle of nowhere doing engineering. But anyway, impurity, the concept of it basically means if it's not in my Nix code, it's happening outside of the defined behavior. So if I write some Nix code that says, services.nginx.enable, so I'm enabling Nginx, the web server, I'm saying that I want that to be enabled. But something else happens as a result of maybe the internet or some other input to the system. That is an impurity. Let's say that Nginx, the first thing that Nginx does when it starts up is download a library, compile some software, and then put it in a directory in the file system. That would be an impurity. And that's something that we aim to solve with Nix. And a lot of programs do this sort of self-updating behavior, like Discord, for example. If you download Discord and install Discord, the first thing it does is ask Discord, is there a new bunch of files for me to download and splat all over the file system of my home directory? That doesn't happen with Nix, and programs that behave like that either have to be fixed by force using a concept called enforcing purity, or they simply don't work on NixOS. So it fixes these anti-patterns in software development.
Very interesting. Very interesting. Okay, cool. Is there anything else you want to tell us about, the Nix package management system before we dive into the NixOS side of things?
Okay. Well, one thing is that a bit of a warning. It's a rabbit hole. Reproducibility and determinism is a rabbit hole because most of what we do in software development today isn't scientific. What I mean by that is you can't reproduce things, and that has gotten worse over time. Nix tries to fix that and is successful in a lot of cases, but can't fix it in every case. For example, Anaconda, the package manager, or Pacman. These are two package managers which often leave the system in a bit of a strange state. And there's nothing we can do to fix them. All we can do is say, use Nix, and hopefully your experience will be a bit better. But you'll have to be a bit of a programmer with a programmer mindset in order to use it. And things are getting better on the user experience side. In my view, it's quite simple to use, but people have a lot of issues with it because it's a very different mindset. So I wouldn't go into it with the expectation of apt install this, Pacman install this, doing a bunch of commands in sequence, getting your system into a state. And then all that sort of mindset doesn't work with Nix. So you've got to be prepared to say, my system is code, and it can't really be any other way, right? And so it's kind of difficult for people to grasp.
I'm trying to kind of grasp this myself. Okay, so maybe you can kind of walk us through let's talk about NixOS, and then we can kind of merge these two together, right? And start talking about them in conjunction. So NixOS, right? Tell me, what is NixOS? How does NixOS differ from Ubuntu, or I know it's not Debian, right? So how does NixOS differ from things like Ubuntu or Fedora or whatever? So what are some of the key differences here? What makes Nix unique, NixOS unique?
Sure. So I kind of touched on that a little bit. So Ubuntu is a model of computing where you apt install the thing, and then you apt install another thing, and then you apt install another thing, and somehow you end up in the state that you want, right?
That's I call that like building your developer environment, right? Like you're building.
Yeah, exactly. You've got to build a developer environment. And, when it gets down to Android and some things like that, it can get really hairy. But Nix is not like that. Nix is opposed to that way of thinking. Nix wants to give you the ability to write in the Nix functional programming language. I want this developer environment. I want Android. I want Android Studio tools. I want Vim. I want Visual Studio Code with these plugins installed, etc. You can put that in like a 20-line Nix file or whatever it happens to be, and then you run one command, and then you have everything that you wanted that's been defined in that Nix expression. And then when you exit the shell, it's no longer there. So you don't pollute your system over time. You don't install things over time, forgetting that you installed them in the past, and then wonder why something's not working. Oh, it's because that thing's installed that I installed last week, so it's causing a bit of an interaction that's caused my system to behave strangely. These things go away in favor of a declarative functional programming language where you define everything that you want in a file, you run one command, and then it's there. And then you exit the shell, and it's gone. Right? So this is what NixOS is, and Nix in general.
It sounds a lot similar to building a container, running your container, and then destroying your container.
Sure, that's a fair point. Yeah, but the way that Nix does it is a little bit different. Docker uses this idea of a layering system, which still sees you writing a Docker file where the first thing that you do is apt install this thing, and then in another layer you do another sequence of events. These are known as imperative commands. Commands where you run one thing and then another thing and then another thing and then another thing, and hopefully you get the result that you want. So Docker kind of puts these into layers or tarballs, and it's similar in a kind of way. And I think that if you're comfortable with Docker at the low level, you might actually be quite comfortable with Nix, understanding the way that it doesn't treat a sequence of events as a layer. It treats the final component as an output or a result. Let's say that I want to compile hello world, right? I'm going to run, the command that I'm going to run is gcc on main.c, and the result is going to be like an object file. And that object file is really what I care about. I don't care about the sequence of commands that I ran to get there. It's going to put this object file or the executable file into the Nix store, and that is called a derivation, rather than what Docker would do, which is called a layer. It would take the sequence of events and it would bundle a sequence of events, run them, and then the result of that is going to be a tarball with a file system hierarchy standard in it, an FHS. You've got /user/bin, you've got /bin, you've got all of these these directories that you're familiar with on Linux. These are what get bundled into the tarball. Nix doesn't do that. Nix only cares about the single result that you've compiled or produced for it to put into the Nix store.
Very interesting.
We'll get into some of that later.
Okay, yeah, I feel like it's going to start coming together when I see this demo, but I want to get a little bit, I still want to build a little bit more foundation here. So you kind of walked us through a bit of the user journey, right? Like, creating this Nix file, and then this is how you bring in all of your, so-called APT files into this Nix file. That's your developer environment. It's this Nix file. So let's talk a little bit about, I'm curious, you kind of mentioned like developers who use Nix maybe need to be on the more intermediate advanced side. I mean, so this doesn't sound so much like a consumer type operating system, right? Like where I kind of feel like, Ubuntu feels like just kind of like the ergo facto. This is the one that, novice new Linux users might go to, Ubuntu, Fedora. But now you've been developing for a while. This is maybe when you move over to Nix, try out NixOS.
It's an interesting question. I mean, I can see a path towards NixOS being a very user-friendly Linux distribution. Right now, it is not, because, for example, we don't have a GUI installer. Right. Okay. So that automatically excludes it from being user friendly. However, once you actually have it installed, it's like Android in a way, right? Android tries to make it a kind of an experience where you move from one phone to another, and then you just have all of your apps there because you log into Google and then you click the button and then you've got all your apps back. That is basically what Nix allows you to do. I mean, the way that Google does it is closed source and proprietary, of course. The way that Nix is doing it is using computer science and building from source in every instance and optimizations. And it feels a bit more like Gentoo in that way. But unlike Gentoo, it's not very, very, very difficult to use. I mean, I just have, say, a 10-line Nix file, which says, I want Firefox installed. I want Nginx to be enabled. I want some other service to be enabled, Grafana, Mosquito, InfluxDB, whatever it is I want to enable. I'll just say services.thatthing.enable equals true. And that's it. It's like a contract. It's just a piece of paper that I'm saying that's how I want my laptop to be. And so once it's installed, it is incredibly user-friendly. It's just once you getting there requires a bit of knowledge with Linux.
And so you can have a bunch of different Nix files depending on what you plan on doing that day. And then you just kind of, boom, boot up that system. That's your NixOS for the day. And that's because that's what you want to be doing for that day, right? So that sounds interesting. Okay. Let's talk a little bit about limitations. I know you kind of mentioned that Nix doesn't have a GUI. What other limitations might you say that Nix has? Because right now, I mean, I guess like in short, what if there's developers out there watching or listening and they might want to contribute to Nix? So I guess, what are some of the limitations? What are some of the things that developers might be interested in helping, supporting, contributing to the Nix ecosystem? And maybe we could go into how developers might get involved with Nix. Where do they go? What do they do? How do they go participate in this community?
Sure. Well, I'd like to actually share my screen at this point.
Let's do it. Let's bring it in.
All right, then. So
there you go.
So this is where every single package in the Nix ecosystem is defined. Every single one of them.
Over 60,000.
No, it's far more than that. Over 80,000.
80,000. You got to update the website then.
Right. So let's say I want Hello World. Here's the Hello package. Here's how it's defined. Here's the source code in Nix code written as for how that comes about. Now, it's a functional programming language. So this right here is a function. The function is called MK derivation. And these are its arguments. Pname equals hello. So that's what the process name is going to be called. This is the version number. That's just going to be available when you do hello -- version. And there's a few other arguments here that you can see, like the metadata, etc. Right? And so this is the package. And if I want to compile that from source, right? Here's what's going to happen. I'm going to go Nix packages, Nix builds, Nix packages, # hello. And that's going to go over here. It's going to read these instructions, and then it's going to build it. And we can even Nix edit, and it'll actually give me the exact same thing I'm looking at on the left. Right? Just to clarify. So let's do a Nix build. The result is going to be in a folder called result. And we'll notice that result is actually a symlink. So result is a symlink to this directory called the Nix store, which is where all of our artifacts from Nix builds live. Right? And let's say we go into the result and go into the bin. There's our hello world. Now, I don't have the program called file to prove to you that this is an x86 compiled binary. So I'm just going to do nix shell-p file. And I'm going to get file. And then I'm going to show you that it is actually hello world compiled dynamically for x86. And that didn't compile anything from source. So the Nix thesis calls this an optimization. I'm able to get the file, the compiled binary, from cache.nixos.org because somebody else already built it for me. So it's an optimization. But if I wanted to, I could actually compile hello world from source. So let's do that now.
Let's do it.
I'm just going to tell it to rebuild. And I'm going to put -l on it so we can see the logs. All right, and this is all happening on the laptop that I'm using to stream from, so I might get a little bit stuttery.
That's all right.
Yeah. In fact, in the meantime, I'm going to SSH into a powerful server. Let's do it there. And this, again, is one of the selling points of Nix, is that I don't need to really care about the tool chain anymore. So I'm going to do the same thing over here, right, and tell it to rebuild.
So now you're SSH'd into a Pi?
No, I'm SSH'd into a powerful machine.
Powerful. Gotcha. Okay. Yeah.
And this is compiling everything from source, and it's done, and it just compiled everything from source the way that it should be on my machine. But if I don't tell it to rebuild, it will actually get it from cache.nixos.org because somebody else has already built it for us from source.
Gotcha. Okay. So
and this applies to all 80,000 packages, right? I can do that for all 80,000 packages.
Okay. So this is interesting, actually. So okay. I'm starting to, I think, understand this a little more, right? So when you say packages, right? Like when I think of a package, traditionally, how the previous Linux flavors have kind of dictated the term package, is that a package is like an application, an object or a tool, right? Like I want to install Git, I want to install Vim, I want to install Python, I want to install whatever. It seems that a Nix package is almost kind of similar to a full-fledged program that already contains the tools in it. So you are creating a package. That package has the tools and the code to run a program in it, all in one. That's the package.
Yeah, so it is the instructions of how to build software from source.
Okay.
But it is also the thing that is computed in order to tell us whether we can fetch it from cache.nixos.org. So like the actual file that I was showing you earlier, which I'll share my screen again. So this file, in fact, yeah, let's go into the Nix REPL and let's start evaluating some of this, right? So I'm going to load Nix packages. This is kind of like C, right? Like the inside of these chevrons here. So that's like an include and say, that's kind of the same notation. So Nix packages results in a path to the Nix store. And what is that? That's the Nix packages repo from GitHub. That's the same as this. So let's do that again. So you see here, I'm going to evaluate that in the REPL for this language. And it's going to result in a path to the root of this repository, right? It's already here on my system. So I'm going to colon area, I'm going to load it. And now I have all 80,000 packages in scope in the namespace packages. So packages.hello will evaluate to a derivation, and then I can build that derivation. And the result is hello on my system, /bin/hello, it's all there, right? So it actually computed this derivation.
So you make it look,
by asking for it.
You make it look so easy. You're moving so fast that I'm gonna have to.
My apologies.
I'm gonna have to rewatch this. I'm gonna have to rewatch this at like half X, just to see what's going on.
Sure. Let's do a little bit more. So packages hello has inside of it a lot of functional programming stuff, right? Like I've got functions that come through as part of hello that are members of hello. So I can do override attributes on hello, and I can start telling it, right, using this language that I want hello. If we can find it again, I want to override one of these attributes, right?
Okay.
So let's say that I wanted to fetch the source code from a different part of the internet, right? Like I want to get hello world from somewhere else, or I want to change the home page thing here, or I want to change one of these attributes. These are called attributes in purple. I can tell it that I want to override the attribute src and have it equal null, which is going to fail, right? So that's resulted in derivation. I'm going to build that derivation, and it didn't find null from the internet because it doesn't exist, right? What it did, it tried to pull the source code from null.
Gotcha.
Right. So I could actually tell it to get the source code for hello world from somewhere else just by overriding this thing here. And I can do that in the programming language as follows. Right.
Interesting. Okay, that's cool. Very cool, actually. Tell me a little bit about. Sorry, did you want to go through more real quick, or
I just wanted to show you some more of the power of this thing.
Keep going. You keep going. I love watching this kind of stuff. This is good.
So I can get hello, right? But I can also get a cross-compiled version of hello for RISC-V. And that'll build it from source. It will bootstrap the RISC-V compiler, or I can do the same thing for ARM. Let's do that for ARM. AR64 multi-platform. And what that's going to do is it's actually going to bootstrap the compiler toolchain in order to build hello world from source. In fact, I've already done this once before, so it cached it. That's another thing about Nix, is that it caches everything. If it ends up in the Nix store, there's no reason to rebuild it. Yeah. Everything's cached. It's actually hard to get it to build everything from source again because it's cached so much. So let's do something else. Let's do RISC-V because I haven't actually done that before. So what that's doing is it's actually fetching the RISC-V compiler toolchain that is the cross compiler to compile this source code to RISC-V, if that makes sense. It's doing everything that it can. It's compiling everything from source. And this might take around 10 or 20 minutes or whatever, but this is just to show the point that I can cross compile anything I want to wherever I want using Nix. It's quite powerful.
Yeah, this is very interesting because one of the big things that we've talked about on the show, not you and me, but some other guests, is kind of the new, I guess not so new, but Docker multi-arc, multi-platform. This was a few years ago at ARM TechCon. It was Jason Andrews. He was able to demonstrate, by modifying a few lines of code, that you could run this same container on an AWS Graviton instance. Then you could run it on a Raspberry Pi, and then you could run it on your x86 based laptop. And so you could take the same thing, you could run it on those two architectures, and it's the same container, just with a few modifications. And so here, what you're doing is you are building the exact same source code for ARM, for x86, for RISC-V.
That's right, and it's all coming from this derivation, right? All people have done, someone made a function in Nix packages that I can access called packages cross, right? And what it yields is a package set of all 80,000 packages in Nix packages, except with all of the compiler arguments adjusted for the architecture of choice. That's what that actually does. And we could go into the implementation of that some other day, but at the high level, this is all available and it's part of the infrastructure. And I can just say, I want you to try and compile this binary for RISC-V. And in most cases, it works, or ARM. And we just got the result here for RISC-V. So let's have a look. /bin/hello. And do I have file? I do. So let's do file. So it's a dynamically linked RISC-V binary. And you know what? I could go even further. I could say packages cross RISC-V. I could say packages static .packages cross. I've done that one before. So I did that literally a year ago, but it's in my Nix store, so it's all cached. And the result then is going to be a statically compiled RISC-V binary.
Okay, so let me ask you a question here. So, I mean, right now you're building all of this stuff on your laptop, or are you building it?
No, this is on a powerful machine.
This is on a powerful
I could do it on my laptop all the same, because the Nix expression is independent of where it's run. As long as you've got Nix, you can do everything that I'm doing on your machine. And Nix runs on Ubuntu, macOS, and the Windows subsystem for Linux. You can do this anywhere, and it does not involve containers at any level. None of this has anything to do with containerization.
So how about on like a Raspberry Pi or some ARM-based system? Does Nix run on Raspberry Pi or the Jetson Nano? I mean, would you install that? Yeah. You can run Nix on there, but what you would be better off doing is, I mean, you can if you want, but those machines don't have very much RAM, so you would probably want to do the building on a beefy machine and push it to it, which is part of what I do with Nix as well. I do a lot of pushing and deploying things rather than compiling on the target itself. Gotcha. Okay. So how about Nix for products? Because this does seem like a very good. It seems like a good system for building products, because you build once and then you deploy, right? So, I mean, like if I wanted to put a product out if I wanted to build, I wanted to put something on a Raspberry Pi, throw that inside of a screen and put it on the airport in an airport terminal so that people can go tap directories. Like, I don't know. I'm just making something up off the top of my head, but this does seem like the kind of system that would be ideal for that type of development, productization.
I think that it would be, and that's one of the things that I'm working on. There's this product called the PiKVM, and I'm working on turning its build system away from an Arch Linux-based build system into a NixOS-based one. And I think the results of that will be quite nice. But I don't think that there's many people doing stuff with products with Nix, even though it would be a good tool. I don't think that that's really happened yet.
All right.
Although you can clearly see how it would be a good thing, because you define everything in a Nix file and boom, you build it. In fact, I've got an example I can share with you of me building something from cross-compiling for an Orange Pi.
Oh, let's see it.
All right. All right, there we go. So here's how you use this thing, right? I'm just going to clone this repository. In fact, I don't even need to. I'm just going to go on my beefy, powerful machine. I'm going to say Nix build, GitHub, : and so what Nix has done is kind of turned, you know how you've got a container registry, right? And that's where you pull all your stuff from. What Nix has kind of done is, which is kind of funny, it's turned GitHub and any Git into a registry for itself, which is quite fun. So I can just say Nix build, GitHub, and then the username or the repo owner, which is my name, Nix opie0 system image example, right? And then I can tab complete to see what some of those outputs are. Sorry, it's hashtag tab complete some of the things. So we've got an images output and a NixOS configurations output. I want the images, and I want the orange Pi 0, and that's it.
I wish you could just see. I wish there was a camera like hovering over your hands because I could just hear you, smashing those buttons away.
Clickety clack.
Morning.
So what this is going to do is I've got the Nix expression there, and I made this a while ago, right? So I made this in July 27, 2021. But this is going to build for it successfully as long as the source code for all of my requirements is on the internet. And the reason that that's the case is because we got this flake.lock here, which says that all of our source code is going to come from a fixed point. It's never going to change. So the inputs are the same. So the output should be the same as well. So this is Nix code that produces a cross-compiled image for an orange Pi 0, which I could flash to the orange Pi 0, right? And that's actually cross-compiling for ARM v7. And the resulting image is going to have the following configuration on it, right? It's going to have, oh, it's not in here. Yeah, it's in here. It's going to have the, a 5.12 kernel. It's not going to have the man pages installed, and it's going to be running a podman container with the following environment variables and those ports forwarded. And that's what's going to happen if I was to flash this, the result of this build onto a orange Pi 0. And this is the code that does it. Right, this is it. This is the total code. Right. Very nice.
Okay, cool.
No, this is how simple it can be. You just say, I want the documentation not to be enabled, and I want SDRAM. So,
did you write? You wrote those comments?
Yeah, that's right.
They're good. Slim it down a bit by disabling. That's pretty. I want that 5.12 goodness.
Oh yeah, it's like you can put this on a share. So in hindsight, this isn't very good. Just don't like the documentation. Slim it down a bit. Yeah.
It's funny though. It's funny. All right, so let's talk a little bit about So first of all, Nix kind of feels like it's still in its early adoption phase right now, right? I mean, it may have been around for a while or been kind of ticking along a little bit, but it does still kind of feel like it's in its early adoption phase. So, what are developers doing in the ecosystem? What are you doing? What are your colleagues doing to bring kind of NixOS more front and center? Because I mean, you still have kind of these major operating systems out there. How are you getting developers involved here? Are they just kind of stumbling across it and being like, "Oh, this is really cool"? Like when a developer comes to you and says, "Oh, gee, gosh, I'm so glad I switched to Nix because."
Well, what I would say is that people are stumbling upon it, and they're stumbling across it in waves, and they come and go, and some people stick around and some people don't. The people that stick around really get the problem that we have with environment pollution, not in the real world, of course, in the digital world. So what I mean by environment pollution is this. My screen is sharing right now, right? Oh, no. I'm going to run out of battery, so I'm going to go and get my charger. Oh, no.
That's all right. That's all right. Plug it in. I'll be here. All right, cool. So while Matthew goes and grabs his battery, I will share my screen here real quick. In fact, let me put up the Nix website. I want to show you all where you can find all of this cool documentation that, sorry about that. All right, cool. So if you go to NixOS.org, I already clicked on the learning portal there, but NixOS.org right here, this is what we're talking about today. So there is a lot of really cool stuff. And in fact, as I was poking through the website, I was pretty impressed at how much stuff is there. And this is why I say okay, well, Nix is in its early adoption phase, but I mean, they have put out quite a lot of stuff. And I mean, SEO's got to pick up some of this. Either way. So let's just kind of poke through here real quick. Kind of Matthew already talked about this reproducible declarative, at the beginning of the episode. He was talking about what this means. So, if you're watching this on demand later, you can go back and watch the beginning. They need to update the website because since this was here, this has 60,000 packages. Matthew's saying there's 80,000 now. So, I mean, that's pretty cool. And look, there's even a search engine here where you can actually go and search for a package that you may want, like the Hello World. I'm going to try it out, actually, Hello World. Let's just see what happens when I search for this. There you go. So it takes me right there, and there's the packages that he was actually looking at earlier. And then here's some examples, even so some video examples. And I wanted to show you this this learning portal here because I thought this was really cool. So install, first steps with Nix, and then how Nix works. I mean, like straightforward, right to the point, very cool. But look at all these guides. I mean, there's a bunch of guides. Here's the one for installing Docker or building and running Docker images. Here's one for installing NixOS on Raspberry Pi. And they're pretty robust. I mean, like this is some good documentation right here. Walks you through the entire process. Go down even a little more, and they have an entire technical documentation hub, it looks like. I mean, everything's here. Nix.dev. I mean, let's check that out, right? Like Nix.dev, here we go. Nix.dev has a bunch of documentation here as well. So you can pretty much poke through all of this stuff. Installing Nix, Linux, Mac OS, Windows, Docker, verify installation, shell environments, everything. I'm kind of interested in poking through this and trying something myself, but not right now. So, you know, I guess there's a lot of stuff to kind of look at here. I'm going to go back here one more time. So right now, unofficial wiki, we'll check this out, and then Nix pills. It looks like Matthew has dropped off the call. I think maybe his battery ran out. And we are kind of coming at the top of the hour anyways. So if he doesn't make it back by the time I finish kind of going through or poking through these other two areas, then I might just close out the episode. But if you have any questions, you know, we can always bring it back to, put it in the comments and bring it back to Matthew. He's on Discord and everything, so we can kind of look at that. So right here, this is installing NixOS on a Raspberry Pi. I was already looking at that one. This is the unofficial wiki maintenance, blah, blah, blah. Get in touch. They have a bunch of resources here. I also saw, and I'm not going to go back to this real quick. I also saw that they have a nice community area too here. Let me click this. So from the community area, you can see they have a chat area, matrix space. They also have a forums page, and they're on all the platforms. Oh man, we're looking at actually creating a Reddit page for a subreddit for ARM software dev. Look, you see that, Seb? They have 9.4K members in their channel there, in their subreddit. I think ARM software dev, we could get up to 9,000 members. We should be able to. But yeah, I'm not logged in, but here we go. This is pretty cool. So I mean, you know, they're pretty all over the place from what I can tell. The forums look pretty engaging here as well. You can kind of see there are quite a bit of posts. There's learning, jobs, links, development, bunch of stuff.
I think you've done a better job of selling it than me, actually. In the social aspects.
I was like half burning time, but like half kind of poking through this stuff because I didn't get a chance to really dig in deep on this in the last week, right? In preparation for this, you kind of filled the spot last minute. And so I was looking at this morning and I didn't get a chance to dig through it that much. So, you know, this was kind of actually good for me anyways. But yeah, so you're back. What were we talking about a second ago?
I don't remember, but we'll talk about something else. I mean, how about this? How about we look through my repository and we see some of the things I'm doing with Nix?
Okay, cool. Yeah, I mean, we have a few more minutes anyway, so let's just check that out, and then we'll close out the episode.
Yeah, not before doing what's on my table or what you know, what tech have I got on my table or whatever.
Oh, we got to do what? Yeah. Oh, you want to do that? What's on your desk?
Yeah, let's do that in a minute. I'm just going to show you some of this stuff, and then we'll move into that.
Seb, you heard that. Get ready to hit that button.
All right, so this is my personal Nix configuration repo, right? This is what I do with Nix every day. This is my laptop, it's my servers, it's my phone, it's everything, right? And when I say that, I mean it. So in here, I have this folder called Pixis. And what this is doing is using a library that someone wrote for Nix, which lets you compile Android from source. So I can define my phone. here, and I say, I want Vanadium to be enabled. Vanadium's like a Google free fork of Chromium. I want to enable the updater, and I want it to point to the web root at android.croughan.sh. And I want to enable F-Droid and C-Vault backup, and I want to get these APKs from the internet using a function called packages.fetchURL with these arguments. Right, and this is where I get the source code for my phone, the Android source code. So because it turns out Xiaomi comply with the GPL, so I can do all of this. But yeah, so I build and deploy my phone using Nix, my Android phone. And you can see here I've got some Robotniks configurations, and in between these curly brackets is a list of phones. Pixis is the result of importing that file that I just showed you. So this is like a true functional programming language, right? I can do a lot of crazy things with this thing. And I'm also just going to show you an example of me changing something or enabling something or disabling something using NixOS. So I've got my server here called Swordfish, right? And it is, a bit complicated at this point, but it is code. So I've gotten to that point where I've just defined everything nicely and put it into different files, and it's code, right? It's not different from code. It is code. So it gets as complicated as code. And for example, here's how I use wide area network. This is how I use my USB SIM card adapter thingy. If this wasn't enabled, I wouldn't be able to use it. And let's go and have a look on. Let's see what options we've got to enable, like services dot. What else is there? Can you think of something that's really hard to run by any chance?
Oh gosh, let's ask Hybrid Robotics. In fact, hard to run.
Yeah, any services that are particularly difficult to run.
Oh man, I can't.
Well, how about this WordPress? I've never done this before, so
WordPress could be a good one. Actually, WordPress can be pretty heavy.
So what's that going to do? I kind of want to avoid things with web servers though, because that means I have to configure Nginx and stuff like that.
Let's see.
Are you familiar with the program called NetData?
No.
You've never seen NetData. NetData is like monitoring, and it's kind of like Datadog, right? So let's do that, and we're not going to do it on Swordfish. We're going to do it on my laptop, right? So T480, that's my laptop. In here, in this code file, I'm going to do services.netdata.enable equals true. And then I'm going to run one command. NixOS rebuild switch flake T480. Right? And that's going to enable NetData on my laptop. And again, this is the same machine that I'm using to do the streaming from. So what it's doing is it's going and fetching all of the source code files for NetData. And if it needs to, it will compile them from source, but it probably doesn't, because cache.nixos.org's probably got a bunch of the artifacts already. And then it will enable it, and then I'll be able to browse and go to it on my laptop. So, this is the part that's similar to containers, except it's doing this without containers. Containers are involved at no point in this process. So, systemctl, status, NetData. Is it running? Yeah, it is. Right? And I can go to NetData 127 on the local host on that port, and here's NetData. And now I'm monitoring my laptop, right? I can see how much CPU usage is going on in this call, how much network traffic's going outbound, etc. And let's say that I want to get rid of that. Well, I'll just edit it again, and I'll say remove that line of code, do an NixOS rebuild switch, and it will get rid of the systemd servers, the users, all of the artifacts. Nothing is remaining on my system that would interfere with any other process. It includes the full instructions of how to put it there and how to take it away. So now if I do systemctl status netdata, it's not there anymore. And if I go back to the web browser and click F5, it's gone, right? And that's without containers, that's without namespaces, that's without any of the fancy features that you need nowadays.
So Matthew, real quick here, I feel really bad because I wasn't watching the chat. I should have been. Some questions came in from Hybrid Robotics. He's become our new resident community member now. I think he's joined like the last 10 streams in a row, along with Charlie J. So let's answer these questions. And I feel like we already have kind of answered them, but I'm going to ask them anyways, just so we can reiterate. So the first question is, is this somewhat like a script that controls a build which, quote unquote, always produces the quote unquote same resulting package?
Yeah, it is. And the reason for that is because the inputs are controlled. Every single time that we fetch something from the internet, it's SHA-256 summed. So if it changes on the internet, we know that it's changed because the SHA-256 sum is stored in the source code for our Nix expression. So if it changes, we know about it. We know it's not going to produce the same output because the inputs have changed. So what you said is exactly correct. At least that's the idea of Nix, and it achieves it in most cases. It tries to produce the same results with every build. And if it doesn't, then it will warn you about it.
All right, excellent. Now, the next one, and this, again, I feel like we kind of covered it, but still, let's do it again. If I understand this correctly, I could build the same package for multiple target systems, including ARM, using the same procedure. Is that correct?
Yeah, that's exactly right.
Yeah. And you kind of did that, right? You did it for x86, ARM, and then RISC-V. You did it for all three pretty much. Yeah,
I mean, the sad part is that I can't really give you a good demo because, compiling software takes so long that it wouldn't be very productive to show you it. But all those commands really do work, and every single time. They're not going to stop working unless the source code disappears from the internet. It is reproducible and it is deterministic. And the build processes are all deterministic too. Well, I mean, there are some cases, but those are the weird cases. And you've got like Java. Like Java wants to store system time, which is different for every single second that you run the command. It's different, and it'll put that in the jar file. And then you've got to find creative ways to get rid of that time and stuff. But Nix kind of encourages this mindset at the very least, and it is successful in enforcing purity and reproducibility where it tries. It is successful at doing that.
I'm gonna do a solid here for hybrid robotics because I don't think he's asked this question yet. Though I'm sure it's a pretty simple thing to answer. Has Nix been used for any robotics? Like, have you seen any examples in your community of Nix being used in a robot? I'm kind of curious because we were talking about Nix running on Raspberry Pi, on maybe a Jetson Nano, but like, you have any examples? I'd like to see a cool Nix based robot. Preferably, of course, on ARM, but yeah.
I actually do. Hold on. It's put my YouTube history somewhere because I've forgotten the name of this darn robot, but it cooks food for you.
Oh, a Nix robot that cooks food.
Oh, God, I've got to find this now.
Nix robot food. I'm searching too. Food cooker. Now the kitchen robot that will cook meals from scratch unveiled. These robotic arms put a 5-star chef in your kitchen. You have a friend that was telling me, he's like, I don't care how much the robot costs. I'll take out loans. I'll do whatever it takes. If there's a robot that
rid of the food problem where you've got to cook it yourself, yeah. Totally.
A robot that cooks food and cleans. It has to do both. It has to cook food and clean. I mean, if you're talking about $100,000, $500,000, he's literally willing to take out a loan, do whatever it takes to get that robot. But yeah,
I can assure you that it does exist, and if I ever find it, I'll pass it along to you and him. But yeah, there is a robot out there that's running a Raspberry Pi, running NixOS, that is built on another machine that is pushed to that machine, kind of doing a bit of an IoT thing that runs NixOS, and it's quite successful at doing it.
Nice. Okay, cool. Yeah. So, are you in the ARM software dev Discord server?
Yeah, I am.
Yeah. Okay, so hybrid robotics is in there as well. So if you do find it, just share it in the Innovation Coffee channel. That'd be nice. I'd like to see it. I think that sounds pretty cool. So we're kind of at the top of the hour now, Matthew. This is when we start closing things out. It's your chance to give your shameless plug. Anyone watching now or later on demand, where would you send our viewers to go or to do for you? The floor is yours.
I would say one thing that they could do is join the NixOS unofficial Discord. That's one thing they could do.
Okay, I can grab that actually from the website here real quick. Copy link address. Let's put that right here in a banner. Actually, let's post it in the comments section. If you are interested, this is the Nix Discord, and y'all can join that server right there. This is the one, right? I think I got it in there. In fact, I haven't joined it yet, so I'll join it. Let's see.
Yep, that's exactly right. That's the right link. So that's an awesome place because that's where a lot of the activity is happening. right now.
Very nice.
This is where people stumble upon the operating system itself. Yeah.
Yeah, you guys actually have a really nice online rate. 2,000-3,000 members with almost 1,000 online. That's a pretty strange occurrence, just to let you know. It's usually like 10 to 20%.
I think so too. And in terms of stats, let me show you some things here. This is Repology graphs, right? So they're graphing the amount of packages that people have and the freshness of those packages. So freshness means when were they last updated. And you can see all the way down here is like Slackware or something. And then all the way at the top right is Nix packages. It is above the AUR and it is above every other repository, every other distribution of Linux.
Nix packages unstable. And then you also have Nix packages stable there too.
Yeah, and I can use any package from any one of them that I'd like to. And that's one of the cool things about NixOS actually, is that I can, here, right, when I was messing around with enabling services, right? So, services.netdata.enable equals true. I can switch to that, right? And I can also revert that change by just taking the line out of the file because it's code, right? I just take the line out, I compile it again, and then my system doesn't have net data on it anymore, right? But another way that I can do that, and this is awesome, is that if I reboot the system, I'll be presented with a bootloader, and I'll be able to go back to before I added that, or I can do it right now doing -- rollback, and that'll get rid of net data all the same. So, because every time I produce my system, it produces, the result, and the result is my system with net data enabled, and then I can go back to the previous result, and everything is stateless. So it's very cool.
Excellent. All right, cool. So Matthew, this is it. Top of the hour. We got to close this out. All right. But gosh, it's been a pleasure, and thank you so much for taking the invitation on such short notice and joining us here, talking about Nix and NixOS. I think it's really cool. I think it's kind of like, I think it takes developers slightly out of their norm, right? When you think about, when you think about like what we're used to, right? Like, I mean, standard Linux operating system, Nix seems kind of out there. And to be honest, it's almost kind of like an exciting version of out there, right? Like you kind of want to go tinker with it because it's different and it feels different, right? So I'm excited to poke around the website a little more and maybe even try booting up or running the documentation on one of my Raspberry Pis. So we'll see what happens there.
You will be sucked in. Yeah, you will be sucked in completely. You'll want all of your systems to be running NixOS because once you start, you don't stop because everything's defined as code. It's all neat. I want every machine that I have to be running NixOS because that means I know what's happening on them. Nothing's left out. All the information's in the Nix code. I know what's happening on my systems.
It's funny that you say that because I remember when you were just getting into it, right? When you were just getting into Nix, and then you were messaging me and you were just so excited. You're just like, "Oh my God, I'm doing Nix now. This is so much fun. I'm loving it." Blah blah blah. And I was like, "Oh, good for you, man. That's really cool." And now I kind of understand why. It seems like a very exciting new world, and so I'm definitely excited to explore it a little more. So with that being said, I want to remind everyone, go check out the Nix Discord server. That's it right there. It's also posted in the chat. We'll make sure that it's included in the description as well. We have Charlie saying that he'll spin it up on his Proxmox box later and check it out. So that's pretty cool. And gosh, Matthew, pleasure having you here. Thank you so much for your time. Hour of your time is very valuable. So we appreciate you spending it with us. Thank you.
Yeah, thank you. And I'll come on again and do it better next time. And,
this was great.
We'll continuing.
This is great. But when there's like a good update going on, like when Nix pushes out something big, let me know. Let's get you back on so we can run an update session. We'll learn all about NixOS, Nix and NixOS Part 2.
Yeah.
All right. Cool. So thank you so much, and we will see you next time. I'm going to close this episode out. Everyone who joined us, thank you so much. If you're watching this on demand, don't forget to smash that like button. Follow us on ARM Software Developers. And if you have any questions that we weren't able to get to during the episode, of course, you can post those in the comments. We'll bring your questions over to Matthew. You can also find him on our Discord server. You can find him on the Nix Discord server. And we are here. Go check out Nix.org. Thank you so much. See you next Thursday, 5 p.m. UTC, Innovation Coffee. Here we go. Take care, Matthew. Have a good day.
Peace out.
Bye.